Sir Isaac Newton was a 17th-century mathematician and physicist. He has been hailed as one of the most foremost scientific intellects of all time. He is also regarded as a founding model of modern physical science and mathematical research. He is most noted for his three laws of motion, which bear his name.
According to Newton's first law of motion, an object in motion tends to stay in motion unless acted upon by an outside force. And the same goes with an object at rest. It tends to stay at rest. It does not want to move unless acted upon by an outside force. For instance, we have this car here, a stationary object. It does not want to move. It wants to stay exactly where it is. But, say for example, force acted upon by me, this car will want to go forward. And I will demonstrate it. Now, Newton's first law of motion states that an object in motion tends to stay in motion or rest unless acted upon by an outside force. Now, I'm riding on the back of this car here, and we're both traveling the same velocity. I'm going to actually have fixed mass to this. But if, for instance, the driver were to spike the brakes, I would still be accelerated because there's no braking action on me. Now this penny is at rest, and according to Newton's first law of motion, if I flick this card out from underneath it, it should fall into the glass of water. Newton's second law, which is a mathematical expression, states that force equals mass times an acceleration. Now I am going to demonstrate that mathematical expression on this car. This car has a mass of approximately 2,700 pounds. I am going to accelerate this car at approximately 2 miles an hour per second. I'm going to do that by just applying a small force of about 50 pounds. As with our previous experiment, I was able to push the car. Now, since there's a frictionless or pretty much frictionless surface, and the car has a much larger mass than I do, I should be the one accelerating as opposed to forces against it. We're about to conduct an experiment which will show the law of inertia. What we're about to do is shoot two different projectiles of different masses. First object will have a larger mass than the second object. Now, according to the law of inertia, the heavier object should travel farther. And as we will see, that will hold true.
First we shot a heavy projectile.
Here we go. Nope, that didn't work out.
Ooh, do you see that?
We then shot a lighter one.
It doesn't work.
There we go.
And it didn't go as far.
Now, as you can see, the first one, the more massive one, did travel farther. The gun was elevated at approximately the same angle, and Newton's law of inertia does hold. The lighter one fell quite short of the heavier mass. Newton's third law of motion states that for every action, there's an opposite yet equal reaction. What that means is, for a small mass accelerating at a large velocity, if it strikes a large object, that object will move much, much more slowly. Now, however, if a large object hits
The transfer of energy in these balls demonstrate Newton's three laws of motion.
Newton's third law of motion, for every action, there is an opposite yet equal reaction. According to Newton's second law of motion, which is actually a mathematical expression, it's that if I were to flick this card out from underneath this penny, it would fall into the glass. According to Newton's third law of motion, an object in motion tends to stay in motion unless acted upon by an outside force. We're about to conduct an experiment. Sideways.